has been fascinating, actually, and I think we actually, I was thinking back to Monday morning when I gave the first talk, and I was feeling, didn't really know, how we would communicate with one another, and we haven't always agreed, that's for sure, but I think we've understood each other mostly, and even when we haven't agreed, and we have, and the spirit's been positive, I think. It hasn't been, even the confrontations have had some humor behind them, which is good. But the topics are really quite deep. Let me just, I'm trying to think about, my posterior relative to 2 days ago and what's more on my mind before we began. So let me just raise two issues. Early in my own talk, I made a distinction between optimality and optimal decisions and reasonable decisions, and or someone else may make the distinction between rational and reasonable decisions. I argued strongly, and I think various other people have as well, that with the kinds of questions we've been discussing at the conference, that it's the most we can hope for is something reasonable. Although I think there is, Tony still thinks there is, one right way to do this. So, what's reasonable? So I think each of us, for those who don't think there is just one right way to do things, then you have to entertain a variety of possibilities. And so my own take on this is that once you get past dominance, it's hard to pin things down, okay? That everyone agrees with dominance, but then, so what strikes me more, I always knew this beforehand, but it strikes me more after the 2 days, is what the breadth of views on reasonableness is. So in my own work, I will say I've become subjectively attracted to Minimax regret in a way. I think there are reasons for it. I like the way it operates in particular applied problems and so on, but I've never wanted to be doctrinaire and say that's the way you have to do things. And obviously other people are attracted to Maximin or the maximum expected utility, the intermediate versions of that. And I've always been aware of that. There's been a few references to the Hurwitz criterion, which some people like too, but doesn't show up as much in the literature. But then there are the part that I hadn't been so cognizant of was the distinction between all of those things, which I think are in the realm of formal decision theory in terms of Casey's discussion yesterday, versus the decision support approaches. That's what strikes with there's the human interaction somehow with the formal decision theory, and that's the part that I actually am finding fascinating. I don't feel like I actually get it fully, because part of what I think maybe both with Rob and Yakov and other people who do that think is they want to leave it somewhat unstructured and not pin everything down. And then I think maybe also with the confidence stuff with Brian, that something should be left out of the formal theory, but that always bothers me because I want to pin things down and do rigorous, have some very, well, I want economists like to turn the real world into our theories rather than vice versa. But so I'm just going to leave that out. I'm not going to go. I think this is bugging me, and I understand it fully. And like everybody else, I participate in many, situations where multiple people have to get together and we interact in very informal ways. And I don't know exactly how we do it. Whether it's making tenure decisions or anything else, and accepting journal articles, whatever. So I don't. So I find that an interesting thing that's come up at the conference that wasn't really so much. Wasn't paying attention to beforehand. The second thing I'll say in terms of pushing things forward, I know in talking with Brian and Richard and Casey about what's the point of having this conference. As I guess you have some sense that you hope that this will help you in your project in some ways, and maybe and I think it's very helpful to have specific applied problems in mind, and there's been a fair amount of discussion about climate change problems, and that's quite natural, I think, both because it's extremely important and also because there's much more explicit recognition of uncertainty, even if not perfect. I think from where I come from, I always hold up the IPCC as a wonderful example, relative to what my fellow economists typically do. Despite the problems with the IPCC process, it's much more transparency there than in what kinds of economic applications I know. So I think to have a range of applications that have different characteristics might be a good thing to do going forward, and then you can bring to bear the different approaches to how each of us would do that. Early Monday morning, I spoke of my own interest in medical applications. We haven't really gone back to that. I think they're quite fascinating area, and it's a place where you can make progress because the clinicians and the public health people, they're very aware that they face very tough decision problems. So that would be another one. Obviously, macroeconomic policy that was mentioned by Richard of Hansen and Sargent this morning, and we could go on and on. So I do think it would be helpful to have a kind of a sort of a catalog of canonical applied problems and see how different approaches might deal with them. So those are the two things that are on my mind more now than they were a couple of days ago.
Great. Well, first off, again, I'm just going to tee off a couple of things that I think would be great to talk about, then spend my time with one of them. So this a number of times come up sort of how would you combine models with experts in thinking about various judgments, which I think could be really interesting, important. The formal measures of confidence and how that would inform scientific assessments, I think is really interesting. But I want to talk about sort of ambiguity as a signal for doing a search problem, which I think is interesting, and also an area where, as someone who does decision support and wants to leave things somewhat unstructured, I could really use some guidance from formal theory. And so let me get at this with a story. So we have a deep uncertainty game we play. There's a long version which takes like an hour and a half, but we have like a couple-minute version which we play in workshops and stuff to get the idea of deep uncertainty in people's heads so we can then have a discussion of what to do about it. And so the short version of the game, and I'm not going to give all the details in case sometime you guys get to play it, but I hold up a die and I pose a risk, decision-making under risk problem, and I ask people the answer. And so the first hand that goes up and gets the right answer is invited up to the front of the room, and then they get to be the decision maker. Then I pull out of my little sack a object whose stochastic properties are designed to be completely, indecipherable. And I try to get a discussion going in the room about what the stochastic properties of this, and I invite people up in two camps, this side, that side, they argue for what they want, and then I ask the guy standing on stage to make a decision based on this engineered cacophony. And so it generally works really well. So I had recently done it in Silicon Valley, where the guy who came up did really well with the risk problem, which is pretty trivial. And he immediately looks at this cacophony and says, oh, that's easy. I'm just going to structure a decision where I bet on both sides of the problem. And so, he bought out the ambiguity with a financial instrument he just engineered on the spot. Okay. And so the point is that so much of what you're trying to do, and actually I think one of the core ideas behind many of these robustness techniques is to find a dominant strategy and put information on the table so that you can find a dominant strategy. And then, or at least a set of strategies which are mostly dominant over large points of the space, and then tee up a subjective probability judgment of whether I want A or B. But you're really trying to find a dominant strategy so that one strategy, so that it's pretty much everybody agrees that strategy A, is better than B because the conditions that would favor B are just, there's really no evidence that they're sufficiently likely. And so I mean, I think Mark kind of really crystallized, the notion that, if you got to make a decision right now or you've exhausted your search, you make your best estimate of the probabilities and you choose, okay? Even if there's a lot of ambiguity, even if there's deep uncertainty, but the existence of ambiguity which makes your choice problem hard is often a signal that you should spend more time looking for a dominant strategy, which is adding new options, providing hedges, making something adaptive or something like that. And much of the iterative process of a process like RDM is designed to give people lots of scenarios in a social context where they're comfortable to be creative about hedging options. And then be able to evaluate those and find ways which hedging options might break, because oftentimes if I come up with, which we didn't do with this VC guy, but he was implicitly assuming his market was liquid, which he probably wasn't thinking about at the time. So, once you have a hedging option, then you want to stress test that to make sure that you haven't introduced new vulnerabilities into the system, because hedging options often add feedbacks, right? So you want to set up a search process for coming with good options. And that's, so as I sit here and see all these beautiful formal theories of choice, there's very little formal theory that I've seen, at least for search. And how do I know, how do I get at least a sense that, this is a landscape which is, if I search a little bit more, I may find something, or that I could spend months and all the rest of the client's money and, we're not going to get anywhere and we're pretty much stuck. So if anybody has a beautiful little crystallized model of a situation where more search is a good idea, or where I should be pretty confident that I'm done, that would be great.
So the last few days have really been an incredible learning experience for me. And like any good learning experience, I feel like the net effect is that I'm now much more aware of my state of ignorance than I was before. So in these reflections, I really thought I would take a step back from the content of this meeting and just give a little bit of a rallying call for the contributions that I think decision theory and support and philosophy and economics can make to the vast armies of scientists trying to figure out the climate challenge. So most of the time, I'm really embedded in these topical experts working on extreme events or food security or clean energy transitions. And I think in terms of the overall state of knowledge there is huge recognition that it's relevant to decision making. There is very strong recognition that the state of knowledge is rich in the realm of the risks of a changing climate. So in any case, in these many thousands of scientists working on climate change, I think there's a huge amount of recognition that we have a robust understanding of the risks in a changing climate. We're building understanding of the options. But the wide open frontier in many ways is implementation. How do we actually respond in practice? And how do we go a lot faster than we are right now? So suddenly the science becomes all about informing decisions under deep uncertainty. If I were to grossly generalize across the IPCC working groups, it seems like there is building understanding that a linear model, a deficit model, is not going to cut it. But really it's just at the starting point of figuring out what is an iterative, interactive approach where knowledge can inform decisions under persistent uncertainties where values and goals matter. I'm just going to highlight 4 basic topics in this group that I think could really crack open a lot of the scientific research. Okay, so there's been a lot of talk about what is judgment. I found it riveting, even if I'm sometimes holding on to understand all of the variables flying by on the screens. But I think in the realm of climate change science, that has often been recognized as something, just a statement that value judgments matter. But in terms of actually informing those value judgments, I think it's pretty rudimentary. Most of the scenarios in the climate change space are about organizing research, not really informing decisions, and that feels a major wide open space where something like RDM has been eye-opening for all these climate change scientists, but it just feels like there's huge potential for innovation. Number 2, the realm of uncertainty, another major topic of this meeting. Physicists, ecologists are great at quantifying the quantifiable uncertainties. We are quite aware that those tend to get lost as you head into decision making. But I would argue that most of these disciplines, whether they're looking at sea level rise or pathways of deep decarbonization, get pretty lost in terms of handling the uncertainties that can't be quantified. What do we do in terms of providing ranges of outcomes around those tails? This is a big question scientifically, and I think your community has a lot to contribute. Then into the realm of risk, I think Rob has emphasized for a lot of the climate change community that there should be such things as decision-first approaches, not just predict then act, but still as you go from probabilistic risk to this broader effect on objectives and outcomes, I think there are big questions. And the last thing I'll highlight is just the realm of opportunities. In terms of climate solutions, no one is ever going to wake up and say, I am motivated to respond to climate change. It's not something that is a big motivator. It's how climate change affects people, societies, their goals. And just saying that it's big and scary, I think we have very clear understanding that that does not motivate action. In terms of nations really taking action, you can say, well, China and India are motivating ambitious action more about the air quality benefits. In the US, talking about jobs and security is a much bigger entry point. So I think this question of how do we deal with risk is very well complemented by how do we deal with opportunity or present it to people. And if there's one last thing I'll say, it's that in the IPCC over many years, you would see very different experts working together and they were forced to produce a product. And that being forced to produce a product together drives pretty incredible breakthroughs. And something I'm personally interested in is thinking about what would ideally a conversation among this community in an ongoing way look like with all these topical experts who need your help.
Thank you very much. Wonderful gathering. I enjoyed it very much, and thanks for doing this, and I learned a lot. I'd like to make a few comments. I'll start with some things that are rather frivolous but would connect to the general theme, which is, I think, dialogue and modeling dialogue. So let me start with when we left off with the discussion, what is credible and plausible, whether they are the same or not. And it's not exactly my role as someone who's not a native English speaker to suggest to you what it is. But my immediate reaction was actually having to do with the dialogue, in the sense that when I hear something is plausible, I think, do I believe it if you ask me? Or implausible, I would say, when you ask me, I don't think it can happen. Credible is more when you tell me. I feel that, I mean, would I believe you? It actually comes from the word believe, right? So you have credible source or something like that. So I think the difference, and I wouldn't mention it unless it related also to what I want to say next, and this is that if we model the process by which someone comes and asks you, do you think this could happen? Or whether someone says, look, I think this should happen, then you say it is or it's not credible. I think that's a major thing that pops up sometimes in decision theory, but generally sort of we economists tend to ignore it. So let me give you two examples of one more from theory and one more from say behavioral economics. From the side of theory, Chuck mentioned earlier stronger assumptions that are less plausible somehow or so. That's not always the case, okay? So one thing that you find if you do axiomatic decision theory, which I know you don't want to do, but if you do, you find out over your life that sometimes you present an axiom that is logically weaker and it's a harder sell and it's a stronger axiom. Okay, so just to give a very frivolous example, suppose that I have an axiom that says that for every n something happens, and the weaker axiom is that for every n that is prime, something happens. Now try to present it to an audience and you say, and I assume that for every n that's prime, this and this happens, and people look at you and say, what's that? Right? And the reason is that when we judge plausibility of assumptions, we don't just look at the logical force of the axiom or how many instances would it apply to, but we judge the act of choosing it. And I have in my back of my mind, I'm saying, why is he saying that? Probably he didn't choose the simpler one because it doesn't work for him or something, right? So I think generally we have this Grice principle, the principle of, in the philosophy of language, of that you're saying the simplest utterance that conveys the message, and from what you say, if it's a bit more complex, I can infer what you did not say, which is perfect Bayesian reasoning. But I think this also happens in the discussion of science. And it also happens within what people understand. So for instance, framing effects were mentioned here some time ago. And I remember years back, my colleague at the time, Ehud Kalai, said, what is a framing effect? I mean, you always learn something from the way it's presented to you, which goes back to the issue of a dialogue. So if you take some of the classical examples of Kahneman-Tversky, if you know 30% probability of death, 70% probability of survival, and you could ask yourself, well, why is my doctor choosing to give me the information this way or that way? Because what you are doing, as we teach our students in economics that you should be doing, to model everything, including who gave you the information, what are their incentives. Monty Hall, the three-door problem, is a nice thing to do in classrooms where the message basically is, it's not just information you got, even if you know for sure it's correct, but is who gave you the information and what other information they could have given you, what are their incentives, etc. And we learn from all that. Moving forward with dialogue, there's something a bit more serious, is this notion of rationality. So I don't know about rational versus reasonable, but with some colleagues we try to distinguish between what we call objective and subjective rationality, where they are basically defined by the kind of dialogue that you have. So for us, it's only a perfectly social concept. I mean, the question is, can you be convinced? And so I tend to like this view because I don't understand metaphysics. Did I say like? Okay. I don't understand metaphysics, and so it's easier for me to think of rationality or anything like this that's defined by things by people and their discourse. But there's a big difference between what we call the objective rationality, something that you could convince any reasonable person of, and subjective, that is the right thing, as opposed to subjective rationality, which is what you cannot convince me that I'm wrong in. Okay, so when I think about decision makers, and just to explain this, so think about something like transitivity, one of the most basic things we could have. I believe it's both rational, objectively and subjectively rational, but I think it has different meanings. So if I'm talking about objective rationality, and I say that I believe in transitivity in that sense, I'm really thinking about something like rules of logic, so that if I can convince you that any reasonable person would agree that A is preferred to B, and separately that every reasonable person would prefer B to C, I can convince you that every reasonable person would prefer A to C, and here is the proof. It's like, an axiom schema in logic where they say, you have a proof for this, you have a proof for that, I concatenate them, I get a new proof of that. When I take the same axiom for subjective rationality, it only means to say, look, if I caught you making decisions in a cycle, won't you feel bad about it? Like if I were to show you you're a politician, would you like to have this kind of headlines where I show that you made decisions in a cycle? So in this case, I think transitivity applies to both, but the kind of test that you use is quite different. I think that in the final analysis, all of these definitions of rationality have to be social. The joke that my students have no longer any patience to hear is this guy who's driving on the highway and gets a phone call from his wife saying, John, be careful, there's someone driving in the wrong direction, and says, one guy. So yes, I mean, we might, for all we know, I might be driving in the wrong direction, and all of you might be wrong, but I'll find myself in a mental asylum. I don't think we have any other way to define rationality apart from eventually the discourse. So finally, what I think the main thing about the way decision theory can be useful, I think, has to do with this dialogue that, on the one hand, I think the dialogue is very simple, and this is maybe what some of the founding fathers had in mind in the 50s. You formulate the problem in the mathematical model, you put it on the computer, you get the real data, objective data, you get the result, and that's it. Decision theory / operations research works perfectly, and we have this, most of us have it in our pockets, something like Google Maps, Waze, some applications that tell you how to get from point A to point B, given traffic, that's the shortest path. Don't argue. Okay? You will feel like maybe you should turn right. The application tells you to turn left. Do yourself a favor, turn left. Okay? That's an example where the dialogue between the decision maker and the decision theorist, if you like, is very simple. You present your problem, you get the answer, you stop arguing, you just do what you're told. On the other hand, there are lots of things that are not of this nature, okay? So if you ask me, what should I do with my money? How should I invest it? And my answer is, well, if you have money to invest, it means that you know more than I do. I mean, what can I do as a decision theorist, tell you what to do with your money? But I can try to still help you sort through this argument. The other extreme of the dialogue is that you know what you want to do, and you just call me to come and post hoc come up with a model that justifies it. Okay, so suppose that we had some rules that say that should there be some investigation, you should at the end of the protocol write down a model that justifies it. And my job is to try to write down the simplest, most intuitive, reasonable, whatever model that can justify your decision post hoc, by which process you're confronted with your utility, with your beliefs. I'm trying to ask, what kind of beliefs are needed for this, and you might want to rethink it. But here, and here I think, Tony, is where we differ, because I was very excited to hear your talk about this dialogue and the construction of this. But I think that the rules of the dialogue should also be subject to a dialogue, the dialogue themselves. Okay, so that when discussing with a person, why do you make this decision? How are you going to invest your money? Or what are you going to do in the political scene, etc.? And I insist that the person would give me probabilities. I think it's fair to say on some cases that they would say, look, I don't feel comfortable with this language. Okay, you gave me a model, and I know that you're very smart and you're a professor of statistics, but I don't feel comfortable with this. And I think that part of the dialogue would be to say, well, okay, if you don't have your subjective probabilities, here's another model in which you might have something else. Or if you don't know exactly what utility function you have, maybe multi-criteria, or you can't optimize so satisfies or something. So I think we need to have a larger range, a larger gamut of decision models that, and have the decision makers be part of this choice of which dialogue, which language do we conduct the dialogue in.
I don't know whether to be sort of pleased or disappointed about the lack of disagreement so far, but that's probably coming, right? I just wanted to put one other thing on the table that's sort of a little bit different, but connects in some ways to things that Catherine was saying, which is about sort of institution design and the way in which sort of uncertainty, in a sense, is handled sort of across society. I think there are sort of many features about the way in which science is perceived and inserted in other parts of society that's not sort of very healthy at the moment. I mean, there's a lot of distrust of scientific outputs in the general community. So we can get very angry about the way in which this is manipulated by the press and manipulated by the politicians, but getting angry about it doesn't particularly solve the problem. And I think it's, you know, in truth, part of the issue has arisen from a lack of transparency about sort of the uncertainties involved in scientific work. And I mean, not naturally, scientists don't want to highlight the uncertainties for good and bad reasons, but one of the sort of temptations here is to sort of worry that communication of uncertainty will have a sort of undesirable or irrational effect on the people who receive that information, and so you censor what you communicate in the anticipation that this will be sort of have better. And that may be sort of short-term rational, but I think is sort of terrible in the long run, because you entrench a kind of culture in which there just isn't transparency about these things. And it's sort of, as science becomes much more complicated, which it will do, I mean, as I know, you know, as our knowledge grows, and these problems are bound to get more and more complicated. So I think one thing that a group like this can really sort of contribute to is debate about sort of institutions that could help, you know, manage the interface between the sort of the pure science, the stuff that people are doing in the laboratory and building, and the decision-making side of things. So this sort of, you know, the IPCC, I think, is, you know, one very good example of the way, too expensive, of course, to be implemented very broadly, but at least that's a model of how one can put a sort of interface in that somehow, you know, and which has evolved very interesting ways, I think, of kind of separating the part that scientists ought to be, the job that scientists ought to be doing, the part that the policymakers ought to be. And we can sort of argue about the details about what that is, but at least there's sort of thinking going on about that. And it would be very useful, I think, to look at other domains and think about how procedures like that could be developed, which would manage that in ways that would at least contribute to creating a healthier culture in which uncertainty is understood and acknowledged and sort of explicitly managed in ways that sort of people understand.
Leave the floor with one.
Yeah, I'd like to make two comments in response to things that have been said in the roundtable and also just generally in the last 2 days. The first is the idea of dominant strategy that Chuck mentioned and has been mentioned previously. I accept the idea that when you have a dominant strategy, then it's dominant and one should adopt it. My point is that dominant according to what criterion? Do you have stochastic dominance, or dominance by infogap robust satisficing, or infogap opportune windfalling, or other criteria? So that dominant strategy is a valid idea, but it's not unique, because you can have dominants that are different, and in fact a given situation may have a dominant strategy by one criterion, but not have a dominant strategy by another criterion. So that when one says dominant strategy, maybe I've misunderstood Chuck and others, but when you say dominant strategy, you have to tell me what is your criterion for dominance. And the same thing would be said about rationality. Rationality is with respect to both values and rules of inference. So, you know, the classic case, suicide bombers are not rational? Nonsense, they're rational. They have different values and maybe different inference techniques. But even if we go outside of difficult things like suicide bombers, the mathematical rules of inference are not unique. Brouwer, a century ago, the Dutch mathematician, did mathematics without proof by contradiction. And so he didn't have real numbers, for example. They don't exist for him, and so on. But it's still rational inference in a very mathematical sense. That's my first point. I'll be quicker on the second point. The second point is, I've done some theoretical work, and you have to be pretty arrogant to do theoretical work in this business because you've been preceded by giants. Frank Knight, Herbert Simon, Leonard Savage, Reverend Bayes, many, many very bright people. You need theoretical hubris to contribute, to attempt to contribute a theoretical idea. My point is, in contrast to theoretical hubris, we need vast quantities of epistemic humility. It was mentioned earlier this morning and previously that models are uncertain often because of severe lack of empirical evidence. Richard gave very dramatic examples. The lack of empirical evidence is the small problem. The big problem is that the past does not constrain the future. The big problem and the real source which needs to motivate epistemic humility is that Shackle-Popper indeterminism, that the rules that govern behavior and the laws of the system are going to change in fundamental ways over the next decades. And that calls for epistemic humility.
Maybe we'll try, what was it, this Australian economist rules with one finger if it's a low relevance and two fingers if it's, one finger if it's a follow-up. So I don't know if you have anything to say in reply to it. I'm looking for fingers, no fingers.
I would like to focus my question, or it's a question to all of the panel. I think every one of you could contribute something in the answer to the nexus between beliefs or on the knowledge side and the decision side. I think that's a big hole in the theory, in the decision theory, but I think it's also a significant hole in the practice and comes up always in the difficulties. Yes, you have different ways to describe some frontier or some set of possibilities and so on, which seem to do justice to your deep uncertainty on a descriptive state, but then the question is what do you do with decision making? And there's no clear sense what to do. And that disconnect, I think, hurts also the relevance of this kind of presenting this deep uncertainty information. So to be a little more specific, I think a good example to focus the question is the long-term climate change, global climate change problematic, when we think of what Kathy was mentioning a couple of times, where we have the basically like sea level rise, we have a certain uncertainty about the tails when you have a very low likelihood or events with very severe negative consequences. Not just low likelihood, but there's also significant deep uncertainty about whether it is kind of the upper probability may be non-trivial, but there's no evidence that of any positive probability. So there's real ambiguity there. Now, I think there are at least two fundamental decision criteria which will give you quite different answers. And they, I think, need to be sorted out in practice and in theory. One, and that's by far as far as I see the dominant approach used in actual models and so on, is a version of the minimum expected utility, caution. You look for the worst cases or for the worst scenarios, for the worst priors within the set of epistemic priors you admit. Now, in this kind of problem, that essentially means that any prior I admit as not ruled out by the evidence, any pessimistic prior not ruled out by the evidence will be taken seriously one-to-one by the decision making, because the caution criterion, basic in this case, when I have unambiguously worse states, it will shift the entire prior within my epistemic constraint to the most pessimistic scenarios. So that's, by contrast, that's quite, I think that cannot be really convincing. Number one, it cannot be convincing given a set of priors, a certain description of my deep uncertainty. Second, it imposes kind of the constraint, it imposes the it forces me to think then to be cautious about making the set too large, because I mean then creating. Yeah, okay, but I mean I have to set up. I'm creating and I want to make sure people understand they're on the page. I'm not just throwing out some words. So I'm basically then have a hard time to think about what my set should be, because if I make it too large, based on ignorance, then I'm just unreasonably pessimistic, and that doesn't work. So I think this would be an example where the standard model gives a not viable answer. It's not going to convince decision makers. It's not convincing in theory either, I think. So an alternative way to look at it would be based on the general notion of robustness, which came up a couple of times, which is something like doing reasonably well under kind of over the entire range of admitted priors, but there lacks one kind of example criterion we have is minimax regret. That's not the only one, and so on. One can, but it's it would give a different answer. It wouldn't shift. It would go somewhere in the middle of the admissible strategies. Now, where there's a lot of open theoretical work to be done, but I think it would be important for this to be developed. And in a way, I'm wanting, so partly I would like the theorists to kind of respond how they kind of buy into that distinction, but also the more decision support people, whether they feel that type of distinction rings a bell and would be useful to have theorized from the decision theory side.
Any fingers on the stage?
Well, so I completely agree with the maximum EU thing. I think you're right, unless you can have some sort of something that guides you in the choice of the intervals that you're willing to that you're maximizing with respect to. Then there's a problem that you start calibrating your choice of the interval in order to sort of not be over cautious once you apply the rule, and that's a bad thing. But doesn't something like that apply to the robustness criterion too? I mean, it's still the issue of sort of what's the set of things that you want to be robust to. So so exactly the same point would apply there. You have to have some principled method for determining, what's the space of possible, eventualities that you want your decision to be robust with respect to, and so this arises both in Brian's model and in Yakov's. I mean, so formally we can see what's going on. Sort of, they have these sort of nested rings, right? And then, so that tells you what the interval needs to be. But once you've picked one of those sort of sets in these nested nests, then you've got the answer to the question. But the interesting question is sort of, how do I get that system of rings? So, is this supplied by the confidence notion in Brian's thing? And I guess Yakov has some, so this is something I'd like to hear from him about, sort of what gives him those set of rings. But, so that seems to me to be where the action is that if you want you want to have some way, some method that tells you, look, sort of how big an interval do I need to look at in order to action the criteria that I like. And then, whether it's
Okay, I will be disappointingly practical, but I want to throw out some things that were coming to mind that I don't know how to think about exactly how they interface with decision theory, but they are a few real-world examples of how people are internalizing the deep uncertainty around sea level rise. Okay, so example number one would be the Thames Barrier, which is often pointed to as the best example of iterative risk management under deep uncertainty for a major piece of infrastructure. It's basically an adaptation pathway approach, kind of like what Rob described, where at different points in time, they're going to revisit how much sea level rise has actually happened at that point and then adjust through a series of options from there. So it's basically grappling with the big tails by saying we'll be rigorous and monitor through time. But that's one piece of infrastructure, a really big piece of infrastructure, but it's not the whole risk management portfolio. Okay, then jump to the Netherlands, much more holistic in their risk management approach. They really seem to be able to make things happen around flood risk management in a way that no other region in the world has done. At the same time, they are 50% below sea level, so they don't really have a choice. But one thing that
face the same threat, which makes consensus on dealing with it.
Yes, exactly.
Yeah.
But I think an interesting thing that Rob was pointing out in that example this week is that they have a somewhat arbitrary, well, they have a very stringent threshold. It's something like 1 in 10,000 year flood risk, but they're using pretty arbitrary scenarios of future sea level rise, yet they're able to rally a lot of action around that. And the third example I would draw is that finally, we see a number of cities in the US, for example, starting to get serious about flood risk management because they're flooding all the time in what's called sunny day flooding. And in Miami, when you have water coming up through the bedrock, that's a little bit nastier and triggering decision support. But in terms of looking at potential sea level rise into the future, what we haven't seen in any location is attention to the full risk management portfolio of, protect, accommodate, retreat, to be really simplistic around that, and how that whole portfolio might adapt into the future under those circumstances of deep uncertainty.
Yes, I'm going to push again on this notion that there's a lot of scientific understanding we're not bringing into this because we're so focused on the choice problem and not the search problem. And the assumption behind this iterative risk management and the deliberation with analysis loop I showed is that none of these things, we separate the values, we separate the policy choices, we separate the scientific judgments, but in many problems, none of those things are actually really separable. So just start with climate change. 20, 30 years, yes, that's right, we mostly motivate action by connecting to other things, but 20, 30 years ago, no one had much of a sense that we need to protect our climate future as a fundamental thing. The scientists put it on the agenda because they said, hey, this is a threat you need to worry about. And people hadn't worried about previously, and now there's a cultivation. You talk to young people, and they care about this in a way that older people don't, because this has become part of the dialogue, right, and part of the way they think about the world. And so values were created by the science, right? And then as you think about policy options, it changes your sense of how confident you need to be. And so it's all an iterative process. And so I was framing it early on as the search process, but you need to think about, and so when we do these things as, quote unquote, ad hoc processes, yeah, you want to leave some pieces open, but it would be useful to have a lot better understanding of how, challenges that hadn't previously been grappled with change the way people, think about their options, the way they think about their beliefs, how groups of people are affected who start with different beliefs can move towards consensus or move apart as you give. And that's why I've stuck social choice and various other things up on the slide. But I think it would be, there's a real benefit here to thinking about, the process as you go through. And just one other thing is sort of sometimes is the way we try to set up iterative risk management processes is there's adaptation by design, where we can specify particular things we're going to observe in particular ways that we're going to adapt to that, to respond, and then things that we think are then threatening to the success of this iteration, the adaptation by design, which would cause us to reconvene. And redo the planning. And so again, sort of, different levels of cost in dealing with the problem, at least in a bureaucratic management sense. And so I think there's just, this obviously muddies the waters some in terms of thinking about some of the principles we've been talking about, but I think there's a whole set of questions about which not being able to specify the problem, it being deeply uncertain to begin with, bring into the process of how the analytics and how the information interacts with option formation, value formation, and what we think about, the confidence, what we need to know in order to reach some sort of attractor state, which is, okay, we think we understand this problem at least for a while, and we know how to act.
Just Klaus asked a question, and I'm listening to I'm not sure there were answers. I think we're all adept enough to discuss whatever we want. It's just like politicians, right? Someone asks a question in a news conference, and we just say. But I actually, since it suits me, I'm actually going to return to Klaus's question. Because it suits me, so I'm no better than anybody else on this. So let me actually go back to the more abstract formulation that I think Klaus was, because these process issues I think are extremely important. I don't want to belittle them at all, but there are some big issues within standard decision theory. It's not all boring. There's some hard things. So. So let me just say two things. First, I think what Klaus was first starting, and a lot of this is about in abstract terms, you talk about specification of a state space. So in standard decision theory, you begin with specification of a state space. It's a primitive, and then you go on from there. And a lot of this discussion has been about cases where, about basically the subjectivity of the state space, and maybe you want to have nested state spaces, and bring that in. There are other things that I don't understand, but I know people who struggle with this. Larry Bloom and Joe Halpern at Cornell have been trying to axiomatize, and you probably know the stuff, Saki, much better than I do, but to bring that in as a part of the axiomatization. But so there's a lot of people struggling with that. The confidence stuff does. So that's part of it. But let me just go back to standard decision theory, where the state space is given, and say that there are big issues even there. So I interpret Klaus as saying, look, it really does matter what decision criterion you use, and particularly there's a big difference between max-min and minimax regret. And I say, yes, absolutely. And you really see that. I mean, you can see that in the math, but in the math is, and there are cases where they coincide. Everyone who studies the math knows there are certain cases where the optimal, the value of the optimum doesn't change across states, where max-min and minimax regret give you the same solution, but you see that those are very specific. And then in lots of interesting problems, a max-min solution is very different from a minimax regret solution. So then you say, well, which one? And I've struggled with which, why do I think that minimax regret tends to be more interesting than max-min? Savage began this. I think, some of you I'm sure know, but maybe not everybody, that at least in the English language literature, Savage is credited with inventing the idea of minimax regret in the 1951 book review of Wald in the Journal of the American Statistical Association. I've heard from a German former student of mine, there was actually someone German who did it before, but that was during World War II and it never got any attention. So, but I don't remember who that was. But anyway, what Savage said was that max-min, or he was talking about minimax because he was talking about loss rather than gains, is ultra pessimistic, and no one with any sense would ever do it. And minimax regret is just much more sensible. Now, the reason, you could just make that as a broad statement, the reason why Savage made that statement, and Savage's book review of Wald is not formal at all, he's just sort of talking there, but he had an idea in it which has been proven out. I've seen it in my own work formally, and various other people will do that. If you're trying to do statistical decision theory, use finite sample data. So you could, relate this to, Saki's work, where you're getting a finite number of cases, the ordinary stuff that goes on in statistics, that a max-min decision strategy in many very realistic problems will tell you to totally ignore the data. And then you say, well, that's just stupid, that even if you have 10 million observations, you just totally ignore the data. But if you approach the same problem from a minimax regret perspective, then it actually turns out that you do use the data and you use it very sensibly, and you essentially do the kinds of things that Saki was talking about, is that basically you use empirical frequencies is very close to the minimax regret solution. So I have an Econometrica 2004 paper that did minimax regret of treatment choice with finite sample data, and then that was continued by York Stoya in 2 Journal of Econometrics papers later, and actually shows this, right? So the actual solutions that you get with max and minimax regret, it's not some trivial technical distinction that in practice this would matter enormously. And I do have a sense that maybe not everyone is appreciating, you know, how big that difference is. So now let me add a third one in. Okay. So I didn't know about InfoGap much. It was a kind of word to me that I've come across, but and you know, from my own perspective, after listening to the exposition on it, I find it useful because I want to formalize things in terms that I know. Instead of calling it InfoGap, which is a kind of weird word to me, the idea of robust satisficing, which I think maybe you used and various other people use, I can understand that. I can understand the math of robust satisficing. Is that if you start off, first of all, if you start off with satisficing, basically what satisficing means is you start off with an initial criterion for which there are multiple solutions. So that's the difference between satisficing and optimizing. Optimizing, you're going to find the optimum bang. But with satisficing, you take a weaker criterion, and there'll be multiple solutions, and then you operate lexicographically, which is the given that I have multiple things that satisfy the initial criterion, then I need a secondary criterion to choose among that first group. And so what Yakov focuses on is the notion as robustness, and then optimize and robustness. Now that's, I can, without any change in language, without needing any semantics of an InfoGap, I can phrase that in terms of a standard decision theoretic criterion. And then the question that will come to my mind, which I don't think has been addressed really, and maybe in some of the InfoGap work it is addressed formally, but I haven't seen it here, is if we just took the 3 I talked about, maximum, minimax, 2 that I talked about, maximum, minimax regret, and then if we added as a third this robust satisficing, well, if we took robust satisficing and applied that to the same problems, right? To take it to this problem that I was just talking about getting fine. This is why I think it's so helpful to have a realistic problem. The problem in my Econometrica 2004 paper is about use of data from randomized experiments to inform treatment choice. That's a huge real-world problem. And you get a maximum solution, and it says ignore the randomized experiment data entirely. You get a minimax regret solution, and it says you're pretty close to come to using empirical frequencies as if they're the truth, which is basically a similarity kind of thing. You could phrase it that way. But what would robust satisficing do in that context, right? And I don't have a juxtaposition of the robust satisficing approach with the more traditional decision theoretic approaches. And I think that would be useful, and I think that would be along the lines of the question that Klaus is raising.
Okay, so Saki, then Mark. Was yours a one finger as well, yeah?
Yeah, one. Half
Okay.
finger.
Okay. Taki, and then is yours Taki 5?
Oh, I think it's okay. No, so I want to go back to Klaus' comments and Chuck's. So 2 main things I'd like to say about it, but one is about axiomatizations, and the other one is about pluralism and so on. So I do axiomatizations most of my life, and that's what I do for a living. But given that, I think I tend to say lots of bad things about axiomatizations. Okay, so I tell people mostly, because right now there's a lot of axiomatic decision theory going on, and many people hear from me that not everything should be axiomatized, in particular many things that come from behavioral economics, or we should just listen to the psychologists and see what reality tells us. We should just have theories and not axiomatize. I think axiomatizations are very important when we talk about general paradigms or conceptual frameworks, and when we were trying to be more rational, and here I think this is relevant to the issue. Now, and here I'll go back, and Klaus knows everything I have to say very well, but I'll say it anyway. In the early days of the max mean, which was almost 30 years ago, when I used to present it, and people would say something like, "Why are you so pessimistic? Why are you taking the minimum expected utility out of all of those?" And the answer was, well, look at the axioms. Why do you argue? I mean, don't argue with the representation. This is what the axioms are here for. If you satisfy these axioms, you behave as if, and then there is a set of probabilities. Now, the set of probabilities need not be those that are objectively given. Apart from the fact that what is objectively given naturally in statistics depends on your confidence level as modeled in these papers that Brian and Richard talked about. So, but even if you had a single set of objectively given probabilities, there's nothing that says that your set of priors you want to behave according to is necessarily that. And there is a paper by Gaidos and others who actually formalizes this, that you selected the set that you behave with given or as a function of the objective given set. So, and here I think that the axiomatic approach does have some value, because we can write up many things, and I've seen things in artificial intelligence. You can write down programs and procedures to make decisions that seem reasonable along the way, but they don't always are. And, you know, from social choice, majority vote is maybe the simplest example. So I think that asking also the question of what axioms justify this general approach, not for any particular theory, but the general conceptual framework, be it expected utility or something else, I think is a very useful exercise. Now, given that, I'm for pluralism. So I know it's also tell in every class where I teach the stuff that's mine, I also tell there are many ways to approach ambiguity. It doesn't have to be this. In particular, if you don't like the extreme nature and you want to do something like the KMM, or Bob now had an idea like this, quantify second-order probabilities. You know, from an epistemic philosophical point of view, I can have issues with this, but if it's useful, go ahead, why not? I'm sometimes so pluralistic, I'm really willing to consider even min-max regret. This is just to show how open-minded I am and a true Democrat. So I think that all of this should be brought forth, and then if you have a decision to make and you could consider a bunch of models, and some of them would be based on a given paradigm, some would be on others. The axioms are part of the discussion. Eventually, when you see how many models support a certain decision, what kind of parameters do you need to plug in this model versus that model, and eventually, you know, you do what you do. We know that these models are never perfect, just ways of reasoning, there are ways of judging the reasonability, and that'll be the way I'll be looking at it. I mean, I'd say max mean and min max regret and anything else is just one among some models in which you could try to plug in numbers and judge reasonability of your choice. I don't think there is something that we should pray by.
So a quick reply by Yakov, and then
a quick response. I think Chuck made a very good point, and I agree with what he said. I would just like to clarify one point, that infogap theory is distinctive not in proposing robust satisficing. It's a little bit distinctive in proposing opportune windfalling. But what is particularly distinctive about infogap theory are the infogap models of uncertainty, which connects us back to the epistemic humility that I was referring to. Infogap has a rich capability of representing functional uncertainties, and that's what's distinctive, not the robust satisficing, which is public domain, let me say.
Can I ask you, because on the functional, because that's the part that I didn't understand. On functional, you said that yesterday, and I think I jumped on you, and I said, what do you mean? We always deal with functional uncertainties all the time in decision theory. So I still don't see what it is in dealing with. I mean, my talk Monday morning, I didn't have the time to go through my work on vaccination policy, and there was a function that was unknown, which is it's a dose response function, basically, is how the illness rate in the population varies with the vaccination rate. And all that I knew in my particular formal work was that it was a monotone function that has to pass through a particular point. So there was a very specific function space, and I didn't know anything other than, so I'm dealing with uncertainty in that function space. It wasn't a probability distribution. So what is it that you mean about functional uncertainty?
I'm sorry, I've already lost your microphone.
Yeah, what I'm referring to is the fact that what infogap models allow you to do is represent many different types. and of functional uncertainty. You mentioned that you know that it's monotone and goes to a particular point. You may know it's unimodal. You may have spectral information. You may have information about tails. You may have slope information. So you don't need the word. You can call it whatever you like. Yeah, you don't have to use the word. It's not even in the Oxford English Dictionary. Yet. I sent them a letter, but they'll get there in 70 years.
I think
Okay, I wanted to bring an additional dimension of complexity. So one thing that stands out after these rich days is the interdependence of the various aspects of decision making, and so we just don't need we don't need just decision theory. We need decision support, and we need to have all these things working together. And so an additional thing that we didn't talk about is moral uncertainty. So we did mention, several of us did mention the issue of diversity of values and objectives that different stakeholders may have. But so there is some deep uncertainty also about the selection of the values, and there may be clashes between the various stakeholders and so on. And so when we introduce this additional uncertainty, we could think of it as something that just requires some extension of our formal criteria and say, well, okay, let's imagine that people attribute degrees of credibility or credence to various values, and then we can apply some form of formal decision-making criterion to that. Or we could say, no, that's not enough. We could go more in the direction of helping them searching for the truth or searching for the best thing. And that's where clarifying the arguments and helping them understand the link between basic principles and more specific conclusions and so on can be helpful. And so I wanted to also add that this kind of decision support with respect to moral uncertainty would fit back into the decision support on empirical issues, because, for instance, I've been involved in work on climate policy where we wanted to work on the role of inequality aversion, a value issue on which there is deep uncertainty because people disagree about that. The role of that in the importance of that for the decision on the social cost of carbon and the optimal carbon tax. And we found out that the models were not adapted to that because they didn't describe our knowledge about the inequalities in the various regions of the world well enough so that we could apply the moral uncertainty to the empirical uncertainty. And so we need to do, so when Rob was talking about search, it's search not just about the empirical thing, but what is important empirically also depends on what is important, what is salient normatively. And so this thing, I just wanted to bring this, to flag this additional dimension of complexity.
Just one further extension of that, I think oftentimes what happens in the science is that there's one moral compass that often shapes a disciplinary approach, and it becomes something that is just assumed. So, for example, cost-effective mitigation pathways, you could say that the prevailing thinking on how you model them is driven by carbon pricing. That makes a whole lot of sense. But then in terms of that value spectrum, other people are going to come to it and say, well, show me how to motivate that pathway on the basis of co-benefits or the business opportunities or the leadership. And building out the decision space there is incredibly relevant. Jump to something like species extinction. The wars in Working Group 2 across different perspectives are, do you represent species extinction as an issue because nature has value in and of itself, or because nature serves people? And the science is kind of the same, but you get massive non-transparent disagreements in the science because there's not explicit recognition of how different the implications are across moral compasses.
Yeah, so I completely agree with what you're saying, Mark, and I think very often it's the case that the moral uncertainty kind of washes out a lot of the scientific uncertainty, which we agonize about these models endlessly, but by the time you get to the moral evaluation, these are sort of minor compared to you just don't know how to evaluate these consequences of these extreme events, for example. Sort of how do you compare sort of entire communities being eliminated with a sort of winnowing effect on a big community which otherwise is left sort of standing and so on. It's a very incredibly difficult problems to deal with. I do have one sort of view on these things, which I think it's really completely the wrong way to think about moral uncertainty in the sort of standard probabilistic frame. I mean, the idea that we can somehow kind of get out all the moral theories on, you know, out in front of us and sort of test them against the sort of moral data in some sort of way, or whatever you test these things against. And that, I think that's really hopeless, in part for these same reasons that sort of scoring models can be very difficult, but in part also for the reasons that you guys have been saying, that in some extent these values are, you know, they're shaped by the process. So these are values are not things we discover, they're the things we construct, right? So you know, if you think of it as a kind of scientific search, you know, if you use your model of scientific analysis as your model for dealing with values, then you're going to sort of think of it as something out there that we've got to find. Whereas really the emphasis is on settling on something that, you know, it's more maybe about consensus building, it may be about sort of reconciling different approaches and so on, but it gives a completely different sort of picture of what it is you're trying to do when you're resolving that uncertainty.
Just very quickly, we asked the question back to Mark. When dealing with the moral issues as to how often it's moral uncertainty versus moral disagreement, which is entire, you know, so it could be that everyone in our room, each of us has our own social welfare function, and they really are different. So for some people, they care about animals because that's just what they care about, and for other people, animals are only instrumental for human beings. There's no uncertainty in any of our social utility functions or social welfare functions. You know, this is just, we live in a society of heterogeneous preferences, and there's no dictator, right? This is, you know, this is Arrow and possibility theorem. So I think we need to distinguish on the moral disagreements from moral uncertainty.
No, just a quick follow-up on this. I agree with you, except that, in fact, many of us, I don't think we have a well-defined theory of or a hierarchy of values or anything like that. So we are all searching for our own preferences, right? It's not like the taste between oranges and apples. It's really cognitive, and so it relies on our own theorizing. And so that's work in progress all our life. And so that's why dialogue and discussion with other people who have other views can be very helpful in shaping our own views.
Okay. Just a super quick point on that. Yeah, no, agree with everything that's being said, and just add sort of the further wrinkle which builds on your, you know, it's constructed that, I mean, in some sense, this is part of the policy discussion, that in order, say, to reach an actionable consensus, we've got a disagreement that we need to have people debate with each other and construct at least enough overlap, which needs to be consistent with the science, needs to be consistent with the options, so that we can, you know, move both the options in the context of the science, which we may need to evolve, and moral discussion, so people can at least find some common ground so that there can be action. So it's all part of a process.
Living in the United States, I'm a Maximin on that.
I tend to be optimistic, right? So we're getting back to attitude, right?
I want to touch on this issue. I think there's definitely a part of construction of preferences, and it can be manipulated and framed and so on. But I do think that there are some things that we feel quite strongly about. We feel quite strongly when we see, you know, people dying or animals suffocated or things like that. So, and I think in general, philosophy, while being very normative, I mean, all these aspects have a side of looking at empirical data. I mean, even if you think about counter-examples to utilitarianism, you give an example where basically people feel, oh, that's wrong, okay? Now, okay, we can argue about it, a good model, bad model, but it does rely on some assumption. It doesn't mean that we should do experimental philosophy, but we should admit that something exists out there and some things are stronger than others. On the species issues, I also think that the second issue that appears there is, do you care about the animal as such? Even if you care about animals, but why do you care about species as species? Okay, who cares about diversity? I mean, if I were about to die, I would like you to save me, not because I'm part of the human race or whatever, just because I'm a living organism, right? So, and I think if I were a dolphin, I would feel similarly. But yeah. so that's why I think these kind of questions can help, because part of the questions that now I know that of course biodiversity, there are reasons that you could think about, you know, and try to maybe quantify the reasons for which you want to have variety of species. But these are kind of questions that you could ask and maybe get people to think, why do they care so much about species as such? Is it because of diversity in our zoos, or because we really care about the organism?
Did you?
So I retired just over 9 years ago. And for many years now, as a result, I've had no source of funding to go to conferences. So the only conferences I go to are ones where people invite me to come along or pay my expenses, and usually I have to give a talk like this. So I end up going to oddball places. What's to me are oddball places. They're new areas I've not been in before, because the statisticians know that I've got nothing new to tell them, okay? So I end up talking about things I've mulled over a long period of time to other people. I've been to metrologists and people involved in forensic science and all sorts of other things. This is, when you do that, it's fascinating. It's a big challenge for communication. You have to try and learn what their world is about and try and tell them a bit about mine. This has been by far the hardest of those. And it's because I think I'm not really used to social scientists and their way of thinking and reasoning. You reason and you argue verbally in far more sophisticated and fluent ways than I'm used to doing, and your discourse is wider in many ways. So I've been struggling to get a hold of where you're coming from and where I might be in disagreement with you or not. So to try and give a little bit of an insight into that, back in the 1980s, my first book was entitled Probability, Methods and Measurement. I don't suppose any of you have ever heard of it or seen it. It disappeared without trace fairly quickly, but I still like it. And in this book, I was trying to teach people what subjective probability was all about, having given up on the idea of writing a book to try and persuade people who were frequentists that they really ought to be Bayesians, because it's a lost cause. So the key idea in this was that of measuring probabilities. I had the notion that, as a true subjectivist, everything that I'm uncertain about, I could describe, in principle, my probabilities for this. But it can be hard to do. If I were a super Bayesian, superhuman sort of person that I call super me, who can argue perfectly rationally, who can draw together all the evidence and get all in perspective correctly, and can make arbitrarily precise judgments, comparing a probability of 0.003 with 0.004. If I could do all of that, then I could probably do what I'd like to do and express all my probabilities correctly, and I'm not going to change my mind unless I get new evidence. But I can't do that, so what I do is I try and get as close as to that as I can do. So I call this measuring probabilities. I can measure them directly by just thinking in my head, okay, do I think that's more likely than drawing a red ball from a bag with 3 red balls and 2 black balls, or something like that. I call that direct measurement. But the essence of the book was to say that by using the laws of probability, I can measure things better. The laws of probability are ways to help me to take a complicated thing and break it down, and so that I can actually express things, my thoughts about some of these things, and then build them up to the complicated things. So it's like I know how to say what's the probability for me of tossing a coin 10 times and getting 6 heads. I use a binomial theorem. I wouldn't try and judge that directly. I break it down with the probability laws. So I was always aware that there was a difference between my ideal probabilities, my true probabilities, if you like, and any attempt I make to measure them. So I don't have a problem with the difficulty of expressing probabilities. And in fact, I'm also aware that the less information I have, the harder it is to be precise about how uncertain I am. This motivated in the 90s a paper in which I introduced the idea of the fractional Bayes factor, which was a kind of robustifying idea for when we have very weak prior information about models. So I'm aware of all of these things. So I'm not so different from your perspective in some ways. But what differs, I think, is that every time I'm thinking about what super me would do, or what super me might be able to do, how can I get a handle on that? I'm thinking always about what's the closest I can be to a good, careful Bayesian argument here. Whereas it seems to me that you and many other people, when faced with the idea that, oh, this is hard to think about precise specification of probabilities, you go into a mode of dreaming up new rules and new ways of thinking about them. And that's not my perspective, and that's why I feel I get frustrated by people who I think are dreaming up ad hoc ways of dealing with non-problems. They are problems, but they're not new problems. They're just part of being a pragmatic Bayesian trying to do things. I never dreamt I would be doing practical Bayesian analyses back in the 1970s and 80s. It was all theoretical. It was all a dream that you could do all of this. As we gradually developed the tools and the techniques and the ideas, I got more and more involved in actual applications, and I realized that all of this side of things, which is, in practice you can't do what you'd like to do, but you just try and get close, is a very important driving principle. I know where I'm trying to go, and that helps me to think about the direction in getting there. I'm not trying to dream up new ways of approaching this problem. So, for what it's worth, that's how where I've reached in this meeting. It's been fascinating. I've heard some very interesting arguments. I've obviously been in contact with some very intelligent people. I'm still struggling a little bit to understand where you're coming from, but this is my best effort so far.
I mean, is there anything kind of particularly pressing that anyone wants to say? Or go. In fact, you don't need two mics. One mic, I think, will do.
So, very briefly on Tony's comment, this isn't something new. The argument of whether or not every unknown can be quantified goes back to the very early days. So Pascal, which gave us subjective probability with the famous wager and gave us lots of things, including dominant strategies, including expected utility. The subjective probability already mentioned. Putting humans at the center, fantastic thing. Also says at some point, and should you not know what the probability is, then it gives you the argument that we now call the unanimity, the range. There is a piece by Glenn Schaefer trying to argue that in Jacques Bernoulli's writing, he also believed that when it comes to a court case, you don't necessarily have beliefs. And I'm not sure, and I've never read the original Latin, so I don't know, but at least there is an argument. The argument has been there, I think, since days of yore. For us, it really changed. For us in economics, it changed with Savage. Okay? So Ramsey, De Finetti, but then Savage is the one who really convinced the profession that this is it, and it's amazing, and it's so beautiful that it's, you know, I can't believe I devoted all of my life to arguing with Savage, but it is by far, I think, the most beautiful result in the social sciences. It's fantastic. I think partly we are enamored with the beauty of it. I think this happens to us to some degree. But the argument has been there. It's not like, I don't think that it's a matter of, you know, conjuring up something new every time. Opening up a little bit, I don't think it's so bad. I mean, if you see that, you know, every week there's a new thing, that's fine. And by the way, the economics profession has this kind of reaction. So, in particular with ambiguity aversion, this has been said by people, hey, can't you make up your minds? Don't come up with a new model of ambiguity aversion every year. But the other extreme of saying we'll just keep this one thing and never look aside seems to me too extreme too.
Yeah, on this is not new theme. You and I were actually talking about this at dinner last night, and the Cromwell line, you know, could I be wrong? And I see in the sorts of things that we're exploring is that was a somewhat harder question to ask, at least analytically, in the past. And now with the vistas opened up by lots of computation, being able to deal with the ability to actually stress test your plans, what you're planning to do against many, many different Bayesian interpretations of what you've got. is become sufficiently possible to do in even complicated cases that it seems irresponsible is perhaps strong, but in many cases it is actually irresponsible not to take the analytic machinery you've put together to answer, to say what should I do for hard questions, and just ask in a structured way, what happens if I'm wrong, and is there anything that I can do about it at this point? So that seems to be a very old idea that we now have new tools to implement in realistic cases.
Bang. Okay, so,
yeah.
I would like to thank all. I would like to thank all the institutions that kind of were involved in organizing this.
For the thank you, you've got to be in front of the camera.
Someone outside the camera wants to thank all the institutions that were organized. So the LSE, HEC, CNRS, GREGHEC, and ENS, where we are. No one's supposed to understand any of that. And the French National Research Center, who kind of funded the project of which this is part. So I think I already said this at the beginning. This is part of a project which is trying to bridge foundational disciplines or approaches with problems of application and policy making. And I'd like to thank Nathalie Beauchamp and Clémentine Fourier, who helped us here. And most of all, I'd like to thank the speakers who made this a very pleasant surprise. I was relatively nervous before about what sort of whether we'd be sitting for half an hour sessions just before lunch, twiddling thumbs and staring at each other, and that didn't happen. And hopefully this will be the first of many discussions. So thank you all.